Cool. So let's get started. Hey everyone, this is Indexer Office Hours number 28, and I guess we could jump straight into it by talking about the updates surrounding Ethereum clients, namely 𝗨𝗀𝗀𝗀𝗀 and Open Ethereum. So I know 𝗨𝗀𝗀𝗀𝗀 team released a patch that basically solves a bunch of high security flaws in the software. So if you guys have anything else to mention, feel free. Otherwise, I'll just go over 𝗨𝗀𝗀𝗀𝗀 patch notes and yeah, give me 1 second. Yeah, so the latest 𝗨𝗀𝗀𝗀𝗀 release was 8 hours ago, and it mentions a security fix coming by the Go Ethereum team. Speaking of 𝗨𝗀𝗀𝗀𝗀𝗀, is anyone else having problem running the RPC with the data directory in the arguments?
No problems here. I do run inside Docker using a shared PID namespace.
But are you using the data there flagged
Yes.
for? Okay. Have you tried tracing? Normal subgraphs work perfectly. No overloads, no nothing. But as soon as you hit it with one single trace call, it blows up. Like quite literally, 5 gigabytes per second reads on the RPC or the 𝗨𝗀𝗀𝗀𝗀𝗀 node.
I don't see that. I'm currently indexing about 20 subgraphs, certainly some of which require tracing, and I haven't had any issues.
Very interesting. So Docker is not affected, hey? Well, I guess I could test that in the next coming days, but all I know is that people it's only me and another 3 guys that reported having issues with this the flag itself, and I think there's a release back in a few weeks ago that didn't have this problem apparently, so they're now thinking of reverting back to that release, or at least tagging it separately so people could use it alongside with the security patches that 𝗨𝗀𝗀𝗀𝗀𝗀 team released, basically. So I guess that would be fantastic to have.
Good luck. Happy to help with debugging if that would be helpful.
Yeah, I think I will need some help. But yeah, cool. Right, so Open Ethereum also released the RC7 of 3.3.0. It's been released yesterday, so if you guys have been running it, please let me know how it goes. I'm very curious. Yeah, I think
I want to say about that. One of the reasons that this release is here is because the prior versions had indeed problems with peering, because there was a wrong implementation of the x66 that was introduced for the London hard fork. So the low peers that we have been seeing wasn't just about running higher connections or whatever it was. There was actually a mistake in the code base, and that should be fixed with RC7. Yeah.
Interesting.
You know why that's still tagged as pre-release?
Yeah. I just noticed it. I was just going to my GitHub notifications, and I saw, because I opened an issue on the Open Ethereum GitHub about having low peers, and they started investigating. And then the 𝗨𝗀𝗀𝗀𝗀𝗀 guys chimed in that they would see that they would start rejecting Open Ethereum clients. And it was confirmed that that in the previous versions there was actually a peering issue, and that was because of a a mistake in the implementation.
Right, I remember reading something in 𝗨𝗀𝗀𝗧 chat regarding ETH 65 or something like that.
I'm glad that's been tracked down because, yeah, I know a few of us have experienced peer count issues with OE.
Cool. Should we move forward? Coin, is there anything else you want to mention?
No, I just copied in the issue that I was mentioning. I still need to run the upgrade myself and try it on one server and see if it improves, and then migrate the rest if I'm happy. Migrate back if I'm not happy.
Sounds good. Yeah, please keep us posted. Yeah, one more thing related to 𝗨𝗀𝗀𝗳 and the graph node. So, as you guys may know, there's one subgraph, namely the EIP721, that encountered a bug, which basically had it stopping at a certain block, basically crying about some gas limits being reached. As far as I can tell, the 𝗨𝗀𝗃 team set a limit of 25 million once upon a time, and we were using that limit in the graph node for a while. And the 𝗨𝗃 team then increased that limit. I don't know where it sits now, but in order to have that subgraph to continue to sync, people that are using 𝗨𝗀𝗀𝗳 must update to the very latest version, which has the default gas limit to 50 million, sorry. And they would also need to either wait for the next graph release, which will be in a few days, or set a flag to increase the limit of gas in the graph node. Otherwise, you can't proceed, move forward from the block that I stopped at. If you want more information, I think there's a channel called Subgraph Health, where I've posted a lot of my journey so far debugging this, and yeah, I can confirm that it moves forward with both the latest 𝗨𝗀𝗀𝗳 and the latest graph node. All right, then I guess we could move to the Repo Watch section. So I can see the first link that Goldberg posted is called Near Support. Does anyone want to talk about that? I'm looking at you, Ford.
Hey y'all, I don't personally have any details on that PR. I don't know if anyone here from Streaming Fast, maybe Alex, have something to share there.
Right. So near the chain,
Yes.
There's been work ongoing and things are going pretty good. So I don't know which level of depth here to go through, but using the indexer framework from Near, we're extracting thing, transform that into a fire hose, and the fire hose being integrated in the graph node. That there's a PR open for that, and we currently, so as of yesterday, have a full-blown fire hose loop. There's a few things we need to sort because Near has non-contiguous blocks. It is possible that a block can pass from block 5 to 7, and that's a thing that the stack was not initially made for. So we removed the assumption, while tweaking a few things, removed the assumption of contiguity of blocks. Now that's all going to be put together, and we hope to have Friday, no guarantees here, to have a fully end-to-end, from Near's history. I mean, we might not have finished processing the history there, but at least, a few, like thousands, hundreds, thousands blocks of history plus streaming live. Something going from the Near chain into a subgraph for indexing, so a mapping function doing whatever thing to entities. That's the goal. It's going to be sort of a, the straightest line, not all the depth that we'd like at each level, but things should be working by the end of the week. So that's cool.
Wow, amazing. Glad to see your technology being put at use in real environments now. Cool.
It's pretty cool indeed.
Wow, amazing times going forward, I guess. So how was the work on and was it much complicated versus like any other EVM compatible chains? I know Near is not. I mean, is it or is it not an EVM compatible chain?
No, it is not. So maybe I can give a few caveats or distinctions or differences that might surprise people. So first of all, from the implementation standpoint, Near provides what they call it an indexer framework. So it's literally, hooks in their node, hooks in Rust that you can implement for you to be fed with the data when it arrives. So they created that, which is useful. Us normally at Streaming Fast, we would instrument nodes to create such a thing, right? We would go and put hooks ourselves, but Near has some hooks now, and we're using that to make things simple. So in that regard, we've used like a simplified integration, the one that they already provide. It's not as complete as we would love for the future. For example, it does not have state deltas at the transaction level like we usually like. But it does have state deltas at the block level, which could be useful. Not tied to it as a side effect of a transaction, but still. And on the other side, so what was the other side? Okay, so for consumers or for developers, Near is not an EVM-based chain. Although I think they're offering some layers on top to do EVM dances or whatever, but that would require something slightly different to navigate the EVM state and transactions on top. The native transactions on Near do not have atomicity between calls. So on Ethereum you can have a single call, and then this one does delegated calls or static calls or just calls to other contracts. All of these things are atomic. So you can have literally like a tree of 64 calls, but they're all atomic. If one fails, you can eventually fail the whole thing. On Near, it's not the case. You can have a transaction, because of sharding, right? You can have a transaction that arrives on one shard, it executes, and then it schedules another call to be executed in another block, because potentially on another shard. And so you have another block where you have that second call. Let's say that's, you're doing a transfer for two different tokens. Well, you'll schedule the first transfer, and the first transfer can have a callback and call back the original contract somehow, and then that's going to be on a third block. So you don't have atomicity of a transaction, which might make things a little bit more complex for subgraph developers. And I know the guys at Edge and Node are working to figure out what's the best abstraction we could provide so that maybe you can have a little bit more guarantees of atomicity, or otherwise how can we help best for those indexing in this situation? Because you can't be sure that the transaction has completed his duty until all the sub calls happen, and these could stretch for many blocks, right? They could be stretching for, I don't know, half a day maybe. I think in the worst case, I haven't seen in the code something that limits it in terms of number of blocks. So I don't know if that's helpful picture. It's just a different beast. And the thing we'd be indexing, there's probably the calls themselves, right? The data in the call. So calling this method, and
yeah, I can jump in there. As Alex said, it is a slightly different model, but some things will be familiar. So you can obviously still sort of have block handlers as you do on Ethereum. The key difference, is that where you've got these promises which are which can span across many blocks. So then it really just changes what the triggers you have are, and so once we're kind of thinking about, there's like an execution outcome, which is what's tied to a sort of receipt, which is an individual one of these promises, and the individual promises are each atomic. So then they don't revert, but as Alex said, the overall chain can. So then you have introduces some difficulties while indexing, because you might want to tie your execution outcome back to the original transaction ID, which is non-trivial. But then sort of even within those execution outcomes, there can be multiple function calls. So again, that would probably just be like different layers, like at which subgraph developers can like hook into to say, okay, I'd like to trigger this handler whenever I see a function call or an execution route outcome to my contract, or just on every block.
Wow, very interesting.
Do we expect that as we add more and more networks that have their own, or groups of networks that follow certain execution architectures, that we will end up with fairly distinct subgraph APIs for each kind of type of execution architecture? For example, one subgraph API for EVM, one subgraph API for near, or any number of other abstractions.
Yeah, I was thinking about the same thing. More even that if we're gonna have multiple graph node softwares for each like different chain, because like I see there was some problem related to skipping blocks with zero data eventually, because that happened due to the fact that other chains that were plugged into the graph node essentially had some different requirements, basically, or rather specifications, that eventually created a bug in the way it handles mainnet data in a way. So I was thinking like maybe we could solve some of these issues by just having separate release software for each chain or something.
Hey guys, so actually it's Lucas from Figment. I was actually saving that for later, and like for us talking about forum posts lately, we've actually released today. We've released stuff that we've promised to release a few weeks ago. Sorry for the delay. You may read about that in forum. It's actually two ideas of ours to actually solve some problems, including this particular one. In this proposal, there are still ongoing talks about that. In this proposal, we thought that the best way to actually have would be to have one like very precise interface for subgraphs to communicate with the outer world, and that would be GraphQL. Thanks to that, and thanks to this generalization, you would not need to actually create this per different networks. You may just use the GraphQL to actually have all this information, all the data. I was talking about that once, so I'm shutting myself right now. Just if you're interested on that, there are two posts on forum that are kind of deeply trying to tackle this problem.
Yeah, I posted both of your forum posts in the office hours chat. Thank you very much.
Thank you.
I think to come back to a couple of the other points as well, on having different releases for different networks. I think that's probably not a desirable pattern. But I think you hit on something which is that relevant, which is that like adding many more networks with loads of different types of abstractions. If you were to cram all of that knowledge into GraphNode, then that would get pretty heavy. And so I think that a lot of the discussions between Edge Streaming Fast and Figment are about integrating these different chains, and a lot of that is about taking a lot of the network-specific stuff sort of out of GraphNode into sort of the sort of like upstream parts of that, upstream parts of the stack. So essentially, GraphNode really is just consuming data from these other sources, and we're working out the best way to go about that. I can't remember, Chris, you had another question as well, and I've forgotten precisely what it was. It was about this different subgraph API. Can you just clarify, when you say subgraph API, do you mean from a sort of developer perspective, or the end result for sort of subgraph consumers?
Sure. Yeah. I don't want us to get too far off track for Indexer office hours, but I appreciate the follow up. I totally agree that we probably want to keep one process here and not split by network. And my intuition was that you know, as subgraphs index transactions, or more broadly events that have, you know, fairly differing technical definitions when you get down to the execution architecture of the blockchain, that the subgraph API, i.e., you know, the API version that is specified within the mappings YAML and informs how the subgraph is constructed, how that API, I guess I was asking about whether the intuition is that we land around kind of one abstraction that is generic enough to be able to capture all of the variants, or whether we kind of land up with a set of, you know, slightly divergent, not so much APIs, but more just shapes of abstraction in order to capture the indexing problem best on each kind of, you know, architecture.
Yeah, I think, yeah, it's really good questions, and also something we've been discussing. I think generally subgraph developers will be coming from their own sort of specific network most often. So like coming from NEAR or EVM chains or whatever other chains are added. And so I think, yeah, both across all of us, and I think Figment in particular, we're keen on this, like maintaining this like specifics that people would expect when they come to a new network, rather than trying to create a sort of graph standard, is probably is probably the right approach. That obviously then just means you need many more types, you need a way of managing those things, but yeah, like hopefully that's not too onerous. And yeah, I don't know, Alex or Dugas, if that's your understanding as well of where we've got to.
Yeah, I think we should expect that the APIs will diverge, because we do want to have the best indexing experience for each chain, where you do have access to the chain-specific information. I think the design principle is probably, if we can have standardization without sacrificing functionality, then it's better to have consistency. But if you have to sacrifice functionality, then it's better to have multiple kind of implementations. So the one place where we're most likely to see divergence is in like the specific data that's passed into the mappings. So each chain might have different fields on the transactions, on the blocks, things like that. And so you do want to give like the raw information to the mappings so that you have access to that data. If we can have common abstractions for things like events, because they're really the same, then it's better to keep those consistent. But with the option to diverge.
That makes total sense. Such fascinating discussion. I find myself naturally wondering about how these kind of new subgraph APIs are being designed to fit into streaming fast vision around like parallelizable computation in the subgraph. Yeah. Anyway. Yeah, good discussion.
I think one thing from my side also. So I think that our approach, our proposal is even yet another, and like we were still thinking that maybe it would be worth to actually generalize and let the subgraph authors to actually create those definitions themselves and rely on GraphQL. This way you would need to actually, the GraphQL would be the API. And if you, we're still waiting for community feedback on that. And there are many ongoing conversations in our free teams about that. But if so, then the API would be one. You just need to have a call of GraphQL about the data, and the data itself would be different. And obviously it would be different across the networks. And we also, I guess, all of us believe that it would be best to have the very the data, the format of the data is close to what the network says. So we won't really interpret that and just really leave that to the subgraph authors to do so. And from my side, if you are interested, please, or anyone, I'm happy to maybe talk more about that and a format, and to have some community feedback on how you guys can see that. interface.
I think there might be potential distinction between unifying on the query side, which I think is really important, that it's as unified as possible in terms of consuming the data. But when it comes to indexing itself, the processing of the data to feed it into the Postgres, basically, if it's better to have distinct processes that are more tailored and therefore have processes that have a smaller code base, so smaller chance of mistakes. I think this is something that could be interesting, or that is not as problematic as lacking the unity on the query side. So on the indexing side, if it means that the networks are too different, and there is a possibility or an option or a smarter pathway to run separate processes depending on the chain, I think this is something that could be an interesting path. We might be sharding databases across between networks anyway. So if it's more suitable or more easy to manage to have distinct indexing processes depending on the chain, then yeah, I think that's definitely an option.
I have a question more of related to. Oh, sorry, Yaniv, did you want to say something?
Well, I wanted to add something to the agenda. I don't know when a good time would be to do that.
Sure, go ahead.
Okay, yeah, it's separate from what we were just talking about, but I did want to make sure that we would have a chance to discuss what happened with the synthetic subgraph over the last week.
Yeah, that's definitely something that I want to discuss.
Okay, perfect. So yeah, whenever it makes sense.
Right. Yeah, we could do it just after I wanted to ask, I think, Adam and maybe Ford, have you guys considered moving to a kind of a GraphQL native database instead of Postgres? Because Postgres is doing some magic to allow GraphQL calls, as far as I know, and it's not GraphQL native.
Is there such a thing as a GraphQL native database?
Yeah, there's many of them, I think. I had a list at some point.
I mean, it's probably worth, making the distinction between graph databases and GraphQL native databases. The only one I'm aware of is dgraph.
Yeah.
But yeah, I mean, there's a lot of engineering that goes in through the layers, and Postgres is a beautiful thing, and there are good reasons for choosing it.
Yeah, I mean, GraphQL to me, sometimes we over position it, I guess. It's a very beautiful language for declaring a shape of a query and the expected values. But that's GraphQL. You can put any database behind GraphQL and make it respond in that fashion. So to me, it's more of an interface. That's why I'm wondering, like, even dgraph doesn't have pure GraphQL semantics. There's no objects in there for you to navigate. It's just that it expresses the database through this language of query. I don't know.
I think it also makes some trade-offs around like how the data is structured and queryable, and like it does assume a data model that is a lot more graph oriented than a relational database.
Right.
But it's also not a very mature piece of software. Postgres, is battle tested.
Yeah, I agree with everything Chris is saying. From my perspective, it would be really interesting to explore over the next few years, like a long term, like once things stabilize with the interfaces, what it would actually look like to build a custom database. It's something that we've discussed like years ago, and people could have different perspectives on the wisdom of going after a custom database. I actually think it would make a lot of sense, but in the future, once we really kind of standardize on the interfaces. Right now, there's still a lot of churn. We still want to figure out what the ad hoc analytics story is. Maybe exploring some more like graph database style queries, what the right kind of constraints are that we can impose on the interface. So I don't think that, that's solidified yet, but in the meantime, it does feel to me like staying with something that's really like hardened and has had as much kind of battle testing as Postgres makes a lot of sense, and that like rather than thinking about migrating to a relatively immature kind of database relative to that in some short to medium term. I think when we do feel like we understand the space a little bit better, actually looking at what a custom database that would meet our specific needs would look like would be an interesting, future endeavor.
Yeah, to build on that, I mean, we've talked about this in a previous Index for Office Hours, but one area where the Postgres databases and many databases fall short is actually on query planning, because they use a set of well-developed but still naive heuristics for predicting like the cost of any query. And you can imagine that once you start exposing database services in a decentralized market, it's important for price discovery and for like market efficiency to actually know how much something is going to cost you. So this is something where I think the work of that Semiotics is doing, applying reinforcement learning to some of these problems of predicting query costs. You could even see that in the future expanded to actually replacing some of the functionalities that the query planner and query optimizers kind of natively do in some of these Postgres databases today. And then last point, just on like kind of the SQL versus GraphQL thing. Obviously, you can't. It's hard to predict the future on where the protocol or how the protocol will develop. But right now, most applications building on the protocol are sort of in this category, that we would refer to as OLTP, which is like online transactional processing. It's the kind of databases that you would normally use to drive like application data. And that's like, all the DeFi apps building on the graph and all the other Web3 apps, they kind of fit in this category of like querying application data. There's no reason that in the future, the graph couldn't also be a decentralized source of OLAP data, which is online analytical processing. That's the kind of thing that was, traditionally done with more like data warehouses. It's the kind of thing that you would plug into like a BI front end like Tableau or like Excel, Power BI. And the kind of, in application development, GraphQL has definitely become the state of the art. In some of these other verticals, the state of the art is still SQL or ODBC. And so, there could be a future in which, the graph supports multiple query languages as kind of first-class interfaces. It's obviously not where we're at today, but it's not something I would write off either.
Yeah, and one of the biggest kind of constraints on the design space there is, which of those queries and like operations we can support in a verifiable way with cryptographic proofs. And so I think that's an area where we're continuing to do research and is going to end up maybe being a constraint on some of the languages we want to support.
Yeah, it's a great point. It might be reduced. It could be subsets of languages or reduced. A reduced set of semantic primitives. But that maintains like wire compatibility with some of these tools that have kind of become standard in the ecosystem.
Super interesting. Well, thank you very much. Chris, go ahead. Sorry.
I was just going to say the idea of building our own database is washing over me and kind of blowing my mind.
I know, right?
Build the economic security and consensus into the database at a more granular level, the efficiency, yeah, wow, that's amazing. Super cool.
So maybe I could throw out here as appropriate, the next step in our pancake swap optimization was to go down to that level, because most of the data systems we built before, because we always tried for parallelism, well, we figured that key value stores are the thing that horizontally scales the best. And so most of our systems have always been through raw key value storage, and that's what today underpins a lot of the, like, I don't know if you guys have seen TIDB, which is a MySQL drop-in replacement. This is built on top of TIKV, which is a distributed key value store, and the whole MySQL semantics are built on a key value store. And if you've seen also, CouchDB, not CouchDB, but CockroachDB, which they're renaming these days, they're also based on a key value store underlying. And so we've always been really excited, and we've done that, like had experience building the databases from that space, and we'd be excited to do that sort of optimization down low at some point.
If I'm not mistaken, I believe the Figment team also brings some really good database design experience to the table. I believe someone at Yaniv, you might know the name, but I believe someone at the leadership level previously worked on TempoDB, which is a really efficient time series database and kind of time series data warehouse.
So yes, from our perspective, from our team, Andy was in the working on that company. That so yes, we also have deep database experience. We haven't really thought about that yet to actually extend graph that much. We're starting from the GraphQL, and maybe let's see what happened. But yeah, also I think that what we and Streaming Fast share right now is the approach that we both internally right now are using, also file-based approach. And this is something that we really need to think about. Do we need the database all the time? And do we really need to store everything and maintain the indices in the memory all the time? Because in some ways, just files might be the better approach. So this is, I think, something we both propose with Streaming Fast to actually maybe just offload the very old data that may be used, but not necessarily all the time. Just store on the drive that is significantly cheaper than just the memory.
Yeah, my understanding is that patterns become a lot more common in the big data world, where you can use things like PrestoDB to kind of have a SQL-like interface, but you're actually essentially querying files in place, that are column oriented and kind of efficient to essentially impose a SQL-like schema on top of after the fact for the purposes of querying. So like using like a PrestoDB against like a Parquet files, for example.
Right, that's cool.
Cool. Hey, and we'd love to make sure that we have enough time to
discuss. I was just thinking about that. Cool. Let's definitely move to that discussion. So, given the last few days, I've noticed in the POI chat that many people have reported a bunch of issues related to a subgraph, which is the synthetics one. And apparently some POIs started diverging, and somehow, I don't know how we ended up in this situation, but like a bunch of POIs are equal to like half the people using random nodes. Like, doesn't matter if it's Open Ethereum or Aragon. It's some people get some kind of equal POIs together, and the other half of the people get like other equal POIs but different from the two versions. So I'm not entirely sure what is happening there. Maybe Ford can.
Yeah, if there are non-determinism determinism issues, that's definitely worth exploring. The first order issue that we noticed, we got a complaint from the synthetics team, was just that all of the indexers were lagging behind pretty significantly. And would love to just kind of understand what was happening there and what we should do about that, separate from the non-determinism thing, which if there's an issue there, we can probably investigate that in isolation.
Cool. Yeah, well, I was thinking, I was seeing it progressing very slow on my on one of our machines, which is using Open Ethereum remote. we're syncing at like 100 blocks per minute, whereas if we use a local Eragon node, we sync it at 1,000 something blocks per minute. I suppose the vast majority of people here are using either Open Ethereum or something like Infura nodes or things like that. So that might, like, latency is very important to subgraph syncing. I don't know why.
Right. So I guess there's a few dimensions to this question. Maybe the first would be to know if anybody is successfully keeping up with Chainhead on synthetics, and maybe what their setup is and kind of like what the hardware resource requirements are to be able to keep up with the Chainhead. And then I think the second question would be, from an incentive structure, why is it that none of the indexers that have staked to synthetics were able to keep up, and how do we make sure that the network is kind of self-organizing to either create the right incentives or right to make sure that the folks that are allocating to a subgraph are incentivized to run whatever hardware they need to be able to keep up.
Right. So I was talking with Adam over the weekend, and one of the pain points of indexers in general is the fact that we don't know if the signal is gonna stay there or if it's gonna be removed, and we're gonna be left with the subgraph waiting for us to get to Chainhead in order to close the allocation. And if that happens, for example, on kinds of synthetics or SushiSwap, that means like for the rest of the month we get to earn no rewards just to sync that subgraph and be able to close the allocation, or close it with a 0x0 POI, essentially giving up rewards up until that point.
I don't think that that's really a problem. Like, we've spoken about how indexers should be doing due diligence on subgraph sync speeds before allocating, and if they do allocate, they're reasonably taking the risk that they can't sync in time. And I mean, that this is not to discount that question, but Synthetics is also a migration partner, I think.
No, it's not.
No, they're not. Oh, okay. Anyway, to your questions, Yaniv, at least I can say I have kept Synthetics Chainhead, and looking at my monitoring, I've been at Chainhead throughout. I'm not allocated to Synthetics, and maybe, to hint at an answer to your second question, I think that unfortunately we're just at a place where the cost structure for smaller indexes in particular means that allocating far and wide is just not viable at all. And that unfortunately means, only one or two subgraphs actually see allocations and traffic from the network. But I'm currently indexing about 20 subgraphs, and Synthetics is one of them, and I haven't had issues. Resource-wise, I have that synthetic subgraph pointed at an index node instance that is probably shared by maybe 5 other subgraphs, and that index node has a dedicated Eragon node. That Eragon node is running an Intel Core i9 processor, NVMe disks in RAID, so it's pretty beefy.
So
Right.
beefy, but sounds like reasonable hardware requirements still. So it sounds like it's most likely that it's not that you need an insane setup to index synthetics, but maybe the issue is more around the cost to allocate and the incentives for the indexers to allocate to that subgraph.
To allocate to subgraphs in general, because I think Jim made a nice Notion page where he basically talks about the cost of allocation for indexers in general.
So I guess there's a few elements there. One is just the I guess it's like the gas cost of running on L1, right? Is that one of that's kind of the main cost to switching allocations?
Yes.
Correct.
Right. So we know what we need to do there. Unfortunately, it's probably going to be a little while until we can move those contracts to an L2. And then I guess there's this other question, Brandon. I'm curious to hear your thoughts on it. It just feels wrong to me that indexers that are severely behind and can't actually like serve data are getting the indexing rewards, that in a sense crowding out rewards from indexers that are like, you know, keeping up.
Sorry, I was muted. Yeah, it's a fair point. I mean, some of these things also relate to the move to L2. So like right now we have epoch lengths of a certain duration. We have allocation lengths of a certain duration. Many of those things were set with the limitations of L1 in mind. I could definitely see a world when we move to L2 in which those things are tightened up. And, you know, so right now, for example, to collect an indexing reward, you need to just submit a correct POI for the beginning of that epoch. And then because of we don't currently have like replay protection on the submitting POI or closing allocation transactions, we actually also allow you to submit for the previous epoch. So effectively that gives you 2 days of behind that you could be and still collect indexing rewards. I can definitely see an argument for tightening that up quite a bit. I think that will probably, I'd love to hear from indexers on that, but I suspect that would probably be a tough pill to swallow until we tighten up some of those durations in the protocol economics, which I think will be easier once we're on L2.
Yeah, can't wait for L2.
Yeah, I think at this point, such a move might implicate that the bigger subgraphs might see even less indexers on them, because we all know it takes time. And yes, you can pre-sync or you can try to guesstimate your sync time, but it's still consuming resources. Even if you're doing your due diligence, it will consume resources. And I think in general, that might be one of the reasons why there might be less indexes on these huge subgraphs like synthetics and sushi. I think either or both have seen quite a number of updates since they published, and then I remember that I'm syncing them, and that before I finished pre-syncing them, they already published a new version. So all the sync work you have done, all the resources you've put in, is basically null and void. I understand it's part of the network and how it behaves, but it definitely doesn't make it easier, and it definitely doesn't make it more appealing to go after these very huge subgraphs that are simply a lot more demanding on your infrastructure than some of these subgraphs that you can sync in hours or in days.
Yeah, I totally agree with you there, Coin. And even if I'm looking now at the spreadsheet showing me the number of stake tokens and the number versus the number of signal amount and signal tokens, and I can see that both Sushi and Synthetics have a kind of a very optimal rewards generation for them. So I'm not entirely sure. Like, I think on Synthetics there's just a bunch of indexers with huge amounts of GRT that have taken the whole supply basically for them. It's basically that. Because like there's other subgraphs that have many other small indexers. I think LivePeer is one of them. I'm not entirely sure right now. I have to check. But like, yeah, last time I was looking at Synthetics, there was like 5 or 4 indexers with like tens of millions allocated. So that basically reduced the profitability for everyone else, for any new indexers to jump in, because it already generates less rewards, like let's say Sushi, than let's say Sushi, sorry.
Do we have a sense if those like small concentrated set of indexers are keeping up with demand for queries, even if they are keeping up with the chain head for POIs?
Can you be more specific?
In the sense that they can't be because they're so behind chain head. So,
well, Chris had mentioned some that were keeping up with the chain head.
No. So this is a really big problem. At least for a few days, there were 0 indexers allocated that were keeping up with chain head. And so synthetics on the network was basically seeing, day-old kind of query responses.
So the issue here is that the indexers that Chris had mentioned just weren't allocating, because I believe Chris mentioned earlier in this conversation that there was a set of indexers that were fully at chain head with synthetics.
Right.
Yes, I was just speaking for myself.
Yeah,
But I was not allocated. So syncing but not allocated.
Yeah, exactly. Same here. I'm synced but not allocated. I have it on chain head on 2 or 3 databases.
Right. So it sounds like it's a combination of large indexers monopolizing the rewards, along with the issue that because you can monopolize rewards even if you're 2 days behind, it creates the situation where it's unprofitable for small indexers who are up to date to compete against the large indexers that are behind.
Yeah, it's a really interesting dynamic. We could explore doing something here ahead of L2. This is something I don't think we've put a ton of thought into, but I mean, the choice of using a block at the beginning of an epoch was somewhat arbitrary. I mean, well, part of it was that we wanted to make indexers indifferent to when during an allocation they closed, when during an epoch they closed an allocation. We didn't want to create thundering herds in the protocol. So we, as much as possible, we tried to design the allocation and epoch structure such that an indexer could kind of enter and exit as they please. But there could be arguments for either tightening up epoch duration even ahead of L2, or saying that like maybe it's the block, some arbitrary block halfway through an epoch that becomes the canonical block, but that basically kind of creates the thundering herd in the second half of an epoch, because then you can really only close out rewards for that epoch once you've essentially reached the halfway mark. But yeah, so there's interesting trade-off space here. I mean, the other trade-off space, that's been touched on is the trade-off space between curation tax and these frequent upgrades. So you can tell that we're kind of coming up against these fundamental trade-offs, because from the indexers, we're hearing that upgrades are happening too frequently to make sense to keep up with, every subgraph that's upgrading, every week or two. From the subgraph developer side, we're getting, the feedback that the curation tax is, a little bit cost prohibitive in some contexts. And so trying to find the right balance, acknowledging that the curation tax was meant to deter frequent upgrades that hurt indexers. But I think the overall takeaway for me here is that like there's a couple changes that are just so fundamental to the protocol that they make everything better. One of them is L2. So L2 scaling really just makes every problem more solvable. It makes the mechanisms we can use more complex because we worry less about gas. It means we can shorten the period of allocations of epochs. And then the other one is indexer performance. Like indexing performance, especially like the kind of orders of magnitudes that we're looking at with the streaming fast and Figment sort of contributions, like that makes this problem of frequent upgrades 10x 100x less onerous, right? And so I think the sooner we can get to those two things, I think many of these sort of idiosyncratic problems just sort of if not disappear, then diminish substantially.
That makes a lot of sense. I don't know whether this really goes directly to solve any of the issues we've spoken about, but I think it might be interesting to make the process by which named subgraphs are upgraded a little bit more like nuanced or multi-phase. Like if there were some kind of on-chain enqueuing of a subgraph upgrade, then that could give indexers the confidence to begin pre-indexing that subgraph prior to any, signal and therefore rewards migration actually happening. And that could maybe build like mutual confidence that supply has been bootstrapped query or indexing side.
Yeah, that's a great suggestion, and we actually have an issue open that we want to start working on that is pretty high priority, which is actually making upgrades possible with zero downtime, which I think is very related to what you're talking about. So like on the hosted service, when you publish an upgrade to a subgraph, you're running both the old version and the new version at the same time, and the hosted service continues to route traffic to the old subgraph until the new subgraph version is fully synced, and then it swaps over. And right now, that's not how it works on the network. As soon as you upgrade on chain, all of the rewards are for the new version, and it could take time to sync that subgraph. So there's actually potentially no incentive to be indexing the new version until it's synced, to be serving the old version while the new version is syncing. So I think that's very related to what you're suggesting. Would be great to get your input as we kind of work towards a GIP for what the solution would look like.
Yeah, it's a really great point. This also relates to another feature that Yaniv has kind of been brainstorming, which is subgraph sets. So kind of conceptually, the way that security in the protocol and the GNS, works today is you're sort of signaling in the core protocol on a specific deployment. In the GNS, you're signaling on the sort of subgraph name, and that signal is, as Yaniv kind of mentioned, it's a knife edge rollout, right? It's a hard upgrade from the previous version to the next one, which isn't how a lot of apps, develop. Typically, you have kind of N-1 support, for your APIs until you do a migration. We've even seen some dApps that have chosen to keep older versions of their subgraph live just because they're built on, because their protocol development strategy is they do upgrades through hard forks, which means that there's still like a running version of XYZ protocol, that might be, might correspond to some 10 versions ago on the subgraph, versions. And then the other thing that we're seeing is that for a single application, there might be cases where it makes sense to break up subgraph logic across multiple subgraphs. And again, that's sort of, conceptually from a curator's or an indexer's perspective, maybe sometimes you're thinking more in terms of the app, like synthetics, like, Uniswap, as opposed to what are the, 5 different subgraphs and subgraph versions that they're using. And so these are pretty fundamental changes to the way the protocol works. Like these are things that would constitute like a V2 of some of these mechanisms, but they're things we're paying attention to that, as Yaniv said, we'd really welcome feedback on that can help us shape these next iterations.
I had one idea of how to avoid having downtimes during updates of subgraphs was basically something in the lines of when the signal auto migrates, only auto migrate half and keep the new one locked for new curators until everything of the new version of the old version is auto migrated to the new one. This way you don't just cut all the rewards for all the indexers that are allocated to the old version. You just cut half of them. So obviously like half of the indexers will be first to move to the new one, but also keeping the old one incentivized up until like indexers catch up with the new version up the chain head.
Yeah, it's a really great idea. I mean, one challenge with the way that we've built things today is that, for sort of historical reasons, we chose to design the protocol kind of as its own system, and then the GNS as a layer that sits on top of it. Some of what you're describing would sort of imply making the protocol aware of the GNS and the concept of, mutable subgraphs that have continuity across multiple versions. It's definitely in the design space, but because it's sort of a fundamental reworking of how the protocol thinks about these things today, it's gonna be a big lift. But it's definitely, I think there's reasons to explore those paths. I gotta hop, but I really appreciate all the contributions on this.
Yeah, I just realized we're over time. Cool. So, does anyone want to add anything else to what we've discussed, or we can cut it off here? Cool then. I guess I'll see you around next week. Thank you very much for joining Office Hours. This was the 28th edition, and catch you up next week.
Thanks, everyone.